This video covers some information from Chapter 3. There's just a few really important ideas. They're basic. We're going to keep using them throughout the semester. So let me get a slide up here for us. Okay. We'll start with the difference between measured and manipulated variables. A measured variable is simply something that's already true about you. So this could be your age, gender, what school you go to, whether you have a pet, whether or not you went to daycare when you were a kid or had a stay-at-home mom, anything about you that's already true, your GPA, your personality. And these are things that I'm not going to make true about you or change about you. They're just things that I can measure. They're true. Okay, how tall are you? That's something I can measure. Now, there are variables that I could actually assign you to. So think about when we run an experiment and we have different groups and we randomly assign people to these different groups. I decide what the groups are, and I can stick anybody I want within reason in any group. That's a manipulated variable. So some things might be, well, if I'm running a drug study and I'm going to give different people different doses of a drug, okay, I can manipulate how much you get, and I can randomly assign you to how much you get. I can put you in different kinds of classes. So you're taking an online class, and I could theoretically maybe randomly assign people to take only a face-to-face class. Now, maybe practically speaking, that is something that's actually a measured variable because you signed up for an online class, or maybe you're in a face-to-face class watching this video. You got to choose that, and I didn't. Then that would make it a measured variable. It's something that's just true about you that I'm going to go ahead and measure, and maybe I'm interested then in measuring some kind of learning outcome based on that. But for manipulated, it has to actually be something that I could randomly assign you to, or that I did randomly assign you to in my study. If I didn't do that, then it's a measured variable. Now, this is really key because this is going to allow you to figure out if a study you're reading about is an actual experiment, because true experiments have a manipulated variable, something that you can be randomly assigned to. They also have a measured variable, which is the outcome or dependent variable. However, sometimes we have studies that only have measured variables, and those are going to be correlations, okay? And the researcher didn't put you in any group. They're just going to go out and measure some things that are true about you. So if I'm interested in something about freshmen versus seniors and how well you write, well, I can't assign you to be a freshman or a senior. You just are. And then I take a writing sample and I grade it. That would be some kind of correlation. So now what we're getting into is these three kinds of claims that studies make. And this is really going to help us a lot in just keeping things straight in all the kinds of research designs that are out there. We want to come up with information. Remember, this is a way of knowing. And we want to know what kind of information have we come up with? What kind of claim can we make from the data we have? And it really does depend on, well, are the data that we have the product of measured variables or manipulated variables? Now, one kind of claim we'll see is called a frequency claim. It's simply sort of a prevalence, how many people support a balanced school calendar in Knox County? Well, they just ran a survey on that. 52% of parents are in favor, 22% are neutral, they don't care, and some other percent don't like the idea. Okay, that's simply a frequency claim. It's just like a piece of information. Now, I want you to also have another label that you can put with these. So when you see something that's just a piece of information, and again, these are often surveys or polls, X% think this or did that, okay? These are called descriptive studies, and they just give us a little bit of information. Now, if we go forward and we look at something that's an association claim, now we're looking at connections between variables, but they are only measured variables. So if I wanted to ask you, how long did you study for an exam, and then look at your exam grade, and I see there's some kind of connection and association between that, so that people that studied more got a higher grade. Well, that's, you probably recognize as a correlation. It's association claim. It just means these variables are connected in some way. They're associated with each other. They're correlated. It doesn't necessarily mean that one causes the other. Okay, you probably remember correlation does not equal causation. or if not, you're going to learn that mantra in this class. But association claims are most easily recognized by when you're reading a study or a newspaper article or something, and you see that the claim they're making is about things that were measured variables. No random assignment, no manipulation, okay? People that are taller tend to weigh more, okay? People that are older tend to exhibit more self-control, okay? These are simply measured variables, and there's a connection there, some kind of relationship, but it's not a cause and effect. To get to a causal claim, we have to run an experiment. An experiment is the only study design that lets you say X causes Y. And the way to recognize an experiment is there has to be at least one variable where you can randomly assign people to the different levels of your variable, to your different groups, okay? So if I were allowed to run a study where people sign up or maybe have multiple sections of a class, and I decide, okay, I'm going to randomly assign which class gets to learn via video and which class gets to see me live in person and maybe ask questions face-to-face during the lecture. If I could actually randomly assign that, that could be an experiment. That, again, is probably something, though, that more often research like that tends to be correlational. It's measured. We just find people that chose these different kinds of courses, and then we look at a learning outcome. But let's use a drug study again. I think it's easy to wrap your head around that. I can randomly assign you to a dose of drug, and if I find differences, and it was a well-designed study, I can say the different dose was responsible for a different outcome. In social psychology, I could randomly assign you to be in a situation with a different number of bystanders, and then I can measure your behavior during a sort of emergency scenario. What do you do? I have actually manipulated something about the context, and so that's an experiment, and I can say there's a cause and effect. The more people who are present, the longer it takes somebody to report when smoke fills up a room, okay? So when you're doing this worksheet, so let me see, I'm gonna show the worksheet that has to do with claims. Actually, we have two worksheets, don't we? So let me show you this one first. Okay, this is the worksheet where you can get a real handle on this measured versus manipulated. So as you're looking through this, gender, is that measured or manipulated? Can I assign you a gender? No, that's measured. What year you are in school. So you're looking through this list, and what do you see that are things I can't choose for you or I can't randomly assign you to, right? How much you like pizza, that's measured. But there are things on here that I can control as a researcher. You come to my food lab, in this one, and I say I get to choose how many pieces of pizza are on your plate when I give it to you. Okay, that would be manipulated. What else could I manipulate? Look at the bottom two. This is a great example. If I just ask you how many hours did you sleep last night, well, that's something that's already true about you, and I'm simply measuring it. However, if you're in my study and I say, okay, you've been assigned to the group and we need you to only sleep for 4 hours tonight, well, that's a manipulated variable, okay? So take a moment, in fact, pause this video if you need to. Pause the video and finish this worksheet, okay? And let me just show you at the bottom, it does ask you to write a couple of your own examples. What I'd like you to do is actually email me your 2 examples of a measured variable and your 2 examples of a manipulated variable, and email it to my regular UT email, which is bethcooper@utk.edu. Okay, so I'll at least get that one email from you, and I'll know that you're on board with these kinds of variables. Okay, so go ahead, pause the video, do that now, send me an email, and then when you're done, go ahead, come back, and we'll look at the other worksheet. Okay, so the other worksheet. All right, now both of these, of course, are posted on Blackboard with the day that you're supposed to be doing this. And here, what you'll see is I have, what do I got? 7 little descriptions of studies. And I want you to read it and decide, first of all, is it a frequency claim, an association claim, or a causal claim? And once you write down that word, frequency, association, or causal, then go ahead and write down the corresponding study design that from the slide, descriptive, goes with frequency claims, correlational goes with association claims, and experiment goes with causal claims. And we'll make a note here, for correlational and association claims, those can be either actual correlations, where there's a couple of variables that correlate, we have correlation coefficient, but they can also be things that we call quasi-experiments or ex post facto studies. Now, a quasi-experiment is one where it just kind of looks like an experiment, it reads like an experiment, there are these groups that people are in, and maybe they do something and something is measured later. Maybe it takes place in a lab and it seems very experimental. But when you're looking at the variable, you realize, oh, wait a minute, this variable is something that cannot be manipulated. It's actually comparing men and women who are sitting in a lab doing a bystander effect study, or men and women who are doing something, or different ages. And once you realize, like, wait a minute, that's a manipulated or measured variable, not manipulated, then you go, oh, this is not, it sounds like an experiment, but it's not. You can't manipulate that. So this is actually a correlational study, or better to just say a study that gives us an association claim, not a causal claim. So you got to keep out for that. Keep a lookout. All right, so read through these. We can do the first one together just to get you started. So number one, can read there. I want to look at college students in the South, let me see, are more likely to join sororities. So I'm looking at northern and southern schools. I'm looking at the percentage of the student body. Now, an easy way to do this sheet is to first start with experiment. Say, could this be an experiment? Was anything randomly assigned? No, I didn't randomly assign people to what college they went to, what geographic location, and they weren't somehow randomly assigned to join a Greek organization. There's no manipulated variable, so it can't be an experiment. It can't be a causal claim. So that's kind of the highest bar. So now you move back and you go, well, do we at least have an association claim? And to see that, there has to be at least two variables that you're looking for some kind of connection, some kind of relationship. Sure, that's what we see here. We see geographically south versus north, and I'm trying to see, is there a relationship between that and likelihood of joining a Greek organization? So those are the two things I'm investigating, a connection. So you can stop right here. We do have an association claim. If it's something like a frequency claim, you're just going to have a piece of information and not connect it to anything else. So for this one, we have association, it's correlational, and I wanted you to write down the variables that were measured for it. So that would be, if you're northern or southern college, and then whether the percentage who joined Greek. All right, so go through this and work on these, and I'll just say one more thing before you should pause it, finish the worksheet and come back, is I say if you find one that's manipulated, and so it's an experiment, and you're going to find the variables, the manipulated variable is the one that we call the independent variable, okay? Now, independent and dependent variables are something that you're going to have to really get down and figure out here. So let me just show you a slide here. Okay. Sometimes it just takes people years to get these straight, but we're going to get it straight. Okay, IVs and DVs. So the independent variable, it is the manipulated variable. It is the one that is, what's different between my two or three groups. Whatever I've made different, that's my independent variable. If I want to do some kind of study on, how much you watch TV, and I'm really actually going to do this, I'm going to sign up families with like fourth graders. I'm going to say, okay, I'll pay you money to be in my thing. And parents, I have randomly assigned you to make sure your kids have no TV, no screen time, maybe I'll even say all screen time, no computer, no TV at all, for 2 weeks. You're in that group. Now this other group, I'm going to say you can allow your kids to have 30 minutes of TV or screen time a day for 2 weeks. Then I go to another group and I say, okay, you can allow your kids 2 hours a day of screen time for 2 weeks. Then I go to another group maybe and I say, just let them do whatever they want. They can have as much as they want. Okay, what I've just said is my independent variable is amount of screen time. I actually set up 4 levels because there are 4 groups. I had none, 30 minutes a day, 2 hours a day, and then unlimited, whatever you want to do. And I chose that because I randomly picked who went where. That's my independent variable. Now, the dependent variable in an experiment is a measured variable. It's something that comes later. So let's say in my TV study, I'm going to have some, we'll measure their attention span after 2 weeks of having no TV, a little bit or a lot, okay? That's something that I don't randomly assign to. It's a measured variable. It always comes after the independent variable. So if this helps, you can think of the dependent variable, whatever the value is, depends on which group you were in. It depends on the IV, okay? So IVs, DVs, you really got to get those straight. I'm going to want you to identify them a lot all during this class. The independent variable comes first. It's the thing the researcher is in charge of and can manipulate. And the dependent variable comes later in the study. All right, so for now, what I really want you to do is just pause the video, finish this worksheet, take a shot at it. And I know there's going to be some things in here that give you a little bit of trouble, so we'll talk about those. But I am not going to just go through all the answers, because then you just watch and learn the answers, and you don't learn that way. I really need you to just do this. And then we'll have ways for you to ask questions if I don't, hit the trouble spots. Okay, so go ahead, pause the video, try this all out, label them, look for your variables, and when you're done, start me up again, and we'll look at a few things. Okay, did you really do it? Okay, hopefully you did. Let me see. Some of the things that give people trouble on this worksheet we'll be sure to talk about. So let's see. Well, number 2, not manipulating anything. I'm really just getting a piece of information, really just kind of one piece of information, an average speed. So hopefully that's enough of a hint. Now, number 3, am I randomly assigning people to any particular group? No, I'm just measuring some things that are out there. Am I measuring more than one thing? I am. Am I looking for a relationship? I am. So you should know the answer there. Now look at number 4. Aha, random assignment. There we go. That's definitely a big clue there, okay? All right, now let's see, what about IVs and DVs? This is a causal statement. It's an experiment. So my IV is the thing that I assigned people to, and this was color of car. Now, how many levels of the IV do I have? And that means how many groups are there? Let me see, I have red and beige, okay? So there's 2 groups, 2 colors, 2 levels of the IV color of car. And then what am I measuring after that? Their speed. Basically, they're probably some average speed, okay? That comes later. So the dependent variable is speed. And what's another way to remember IVs and DVs? DVs, the dependent variable, you're measuring it the same way in everybody. The IV is different depending on what group you're in, but the DV I measure from everybody. I want to know everybody's speed, okay? Maybe that'll help. Now, 5 always throws people for a bit of a loop. They tend to notice that I'm able to manipulate something, kind of, but they get confused. And so here, think of this. I'm a researcher, and I'm interested, maybe I really want to know, in a very applied research setting, if I put a sign up that says how fast you're going, will that slow people down? Well, I want to try it out. Now, I could randomly assign when the sign is on or off. I could control that. And so really, I've got 2 conditions, sign on, sign off, okay? And since I can randomly assign that, I can have times of day when I'm gonna run my study and collect data. And I can randomly assign which, maybe I do it in 15-minute intervals or 30-minute intervals. And I can flip coins to say, this is gonna be when the interval's on or off. And I'm gonna leave that to chance. I'm not gonna go out there and go, oh, people are going pretty slow, I think I'll just turn the sign off. Or people are going fast, I think I'll turn it on. That would be biased, but I could set up the schedule where I randomly decide when the sign's going to be on or off. I control if it's on or off. And so the independent variable here is sign on or off. There's 2 levels, 2 conditions. It has nothing to do with who's driving down the road, and that's random, and it doesn't matter. I'm controlling the sign on or the sign off, and I'm looking at average speed of cars during these 2 conditions. So that's my experiment. I know that one always sort of throws people. 6, maybe I'll just let you think about that. Ask yourself, am I manipulating anything? Am I putting people into groups? Am I looking for a relationship between anything? Now I do have more than one piece of information, but all I have are pieces of information. I've got people's concerns and I'm grouping them into categories, but I'm not randomly assigning anything to groups. I may have categories of concerns, okay? All right, so the answer is, this is descriptive. It's a frequency claim. And let's take this one, though, and change it into an association claim. What if I looked at students' concerns, but I then grouped them by, did it matter if you're a commuter student versus somebody who lives on campus? Does it matter if you're someone who's in the athletic program or not? Does it matter if you're, do people in the Greek organizations have different priorities than students that aren't? Now I'm starting to connect the concerns to another variable, like commuter student versus on-campus living student. Now that would be an association claim, but I don't have that in this description. So what we're seeing here in 6 really is just a frequency claim. Okay, I'll let you do number 7 on your own. That looks pretty simple. If you have real problems on this or questions still, we're going to use the class blog to ask questions. You can post there, or if somehow you don't know how to use it or feel funny, you can send me your question. But if I typically will get similar questions for students, so I want to post these questions on the blog, and then you guys are going to try and answer them, and after perhaps 5 attempts, I will answer them. But I'm sure I've explained this already. So that'll do it for now. Finish up these worksheets and do the other stuff you need to do for chapter 3. And all right, thanks guys.